Okay, welcome to my presentation. My name is Edona Kurtolli. This is module number 3, titled Human Factors in AI as part of AI Product Management, part of a 3-module type of course offered by Duke University through Coursera. What am I going to talk about today? So I am going to talk about a problem that I've selected. And in this problem that I've selected, I will discuss 4, so to say, elements. These elements include the items that you're seeing on here. I'm going to talk about task analysis, where I'm going to talk about the problem that I've selected and do some basic task analytics on it. Then I'm going to discuss the user experience design, where I will explain how the user will interact with the proposed tool and how some of the key considerations of AI product user experience will be designed. Then finally, I will look at some privacy considerations where, based on just some of the research that I've done, what kind of privacy-related concerns I could possibly have. And then finally, ethical considerations, and if the idea and the product that I described is going to meet the goals of ethical AI, namely 3 elements like fairness, accountability, and transparency. Let me start with task analysis, where I'm gonna identify the key tasks which are related to the problem that I've selected, and then I'm gonna talk about insights from these task analysis. There's a lot on here, but I will try to be as brief as possible. So starting with the problem I've selected, we're looking at inefficiencies in predicting lead times for supplier parts. Where in supply chain operations, one of the challenges is related to material flow, being the unpredictability of lead times for supply parts. These can truly vary significantly based on really a large amount of factors, starting from production schedule to any transportation delays caused by a multitude of factors, and then finally, raw material shortage. When there isn't such a predictability, it creates a lot of inefficiencies in supply chain, and then it affects planning and inventory management, and it leads to production delays, stockouts, and overstocking, like problems like overstocking, for example. On my slide over here, you will see model development flow as well as inferencing flow. And each of these tasks on here will be addressed by, let's say, a collection of elements or activities that will take place in each part. For example, under data collection, I'm looking to collect historical lead times from suppliers, looking to collect anything that is related to data on transportation methods, weather conditions, even the production capacity of suppliers, and also real-time data from suppliers, which we'll address that a little bit later. When it comes to data processing, I'm looking to capture trends, but also to make sure that the data is clean. Any outliers or any anomalies, which is stuff we've learned in the prior modules in this course, are addressed. And the features that are going to be created, which is the next portion here, is anything that captures seasonal trends, supplier reliability, any transportation delays, but as well as things like normalization and standardization. So the idea here is to train a machine learning model to predict the lead times based on the historical and real-time data, and develop the features for the model, such as supplier performance and scores, for example, and continuously update the model to improve the accuracy. I'll get to that in the next slide here, but looking at the inferencing flow below, there are several things that can be addressed on the inferencing flow, but talking about real-time data feed, apart from data collection, which like the historical stuff, we're looking at real-time supply data, transportation data, and any real-time events. When looking at the model in action, The inputs to the model will be based on what I said earlier, but the model will predict the lead time for each supplier and each part, which in action it looks like it should look like it's estimating some sort of arrival. And also it will categorize the risk level if that arrival time is confident enough or not. So the prediction output will be for each supplier and each part, some sort of an estimation when the part will arrive. So the idea is to have this in sort of a visualization manner where some automatically generated alert is done, which causes flagging of the potential disruptions. All in all, this is more or less what I've been looking at as a problem statement and also in the two flows below. But then an important portion on insights and task simplification is something that I want to just quickly address on this slide over here. I have a bunch of bullet points and I don't want to go over every single one of them, but I will start by kind of addressing what my thoughts were around it. On the automated data collection, to kind of reduce the data input from a manual perspective, any type of API link would be helpful with suppliers' existing, let's say, systems. Any type of automated engineering will speed up the preparation of the model by generating those key features I mentioned earlier. And then dashboards that are color coded and that can help with actions. And of course, things like a simulation of a scenario, but then also automated alerts. Finally, the last thing on here that I've put is feedback. Feedback should keep the model updated. And that type of feedback we should be encouraging the user to participate because it will improve the output of the model and the recommendations. With this in mind, we can go to the user experience, where I will try to explain how the user will interact with the proposed solution, and then we'll look at the approach by splitting it into three different buckets, which is the user input, more or less the transparency of the model, and the communication of any uncertainties. On the user interaction, if you see that first bit, it's very basic, but the idea is there for the system to give you, let's say, a supplier name, a part that is being transported, the origin and the destination, and some sort of a prediction that comes out of all the magic that is done behind, and also the mode of transportation. But the idea is for somebody like a category manager or a supplier manager to check this one and then provide feedback if the result was as such, so that it improves the model. The three-point flow that I've put for user inputs and feedback loops, this is what I'm mentioning in terms of kind of confirming and adjusting the result, and also some sort of highlighted of a prediction on the process, saying, for example, highlighting that these trucks normally take this long to get from location A to location B based on the weather, based on the time of travel, and all of that stuff. And then finally, some sort of a color coding. For example, the truck can be, I don't know, in yellow or in red if it signifies any sort of slowness or whatnot. Then when looking at privacy considerations, I have to press a button for stuff to come up here. I'm sorry. There's many things that can be considered here. For example, there's a bunch of applicable privacy laws when implementing machine learning, and there's also a bunch of obligations you have to look at depending on what country you're working in. For example, if you are in the European Union, you have to look at the GDPR, which is the General Data Protection Regulation, which applies to the supply chain solutions which involve individual data, that is. And the obligation here is to collect only the data necessary for the task. So there's it really depends on where you work. For example, if we are also working in California, we have to look at the California Consumer Privacy Act. And also, if we are carrying stuff that is on the medical field, then HIPAA is also to be considered. But also, each country has its own regulation. So we have to look at each applicable privacy law. What is a key consideration here in terms of obligations? We're looking at consent, transparency, data security, individual rights, and data sharing. And at the end of the day, how I can summarize this is that the key here is to have the right certifications and also to be compliant. In terms of ethical considerations, there are a few things that I've looked at in terms of potential sources of bias here. Of course, we're looking at things like, I think I have them listed here, fairness, accountability, and transparency based on what we learned throughout the module. But in the context of using AI for predicting supplier lead times, several potential sources of bias could be there. And some key areas for consideration can be addressed by kind of uh, looking at any of the unintended consequences, lack of transparency, any sort of historical data bias, any sort of geopolitical and regional, bias, any bias in external events, for example, overweighing any temporary disruptions leading to unfair predictions, and just lack of transparency in general on the black box models leading to mistrust and ethical issues in supplier treatment. And also, one thing, for example, bigger suppliers could be at an advantage here because there could be just basically more information about them out there compared to other suppliers. All in all, so I think the key here would be to maintain the human in the loop system where critical decisions can still be viewed by a person, and also have in mind that your AI, your machine learning AI model is only as good as its data and the way it is trained. So constantly feeding it with feedback is key, and making sure that there is that human touch present. I think that's it. Thank you. Stop.